Assalamualaikum warahmatullahi wabarakatuh. Today we are going to presenting our mathematics assignment solution. Firstly, I'm going to introducing my group members. Our group member have three person. First person is Muhammad Karul Farhan bin Mazlan. Second person is me, Fatim Batusha binti Muhammad Roslan. Third person is Nur Amira Zahida binti Hishamuddin.
So, before we go through the question, I will explain what is Fourier series. The Fourier series is a mathematical tool used in engineering mathematics and signal processing to represent a periodic function as the sum of simple sine and cosine functions. It was introduced by Joseph Fourier in the early 19th century. The main idea behind the Fourier series is to express a periodic function with a certain period t as an infinite sum of sinusoidal functions. The general form of a Fourier series for a function with period L is given by a naught over 2 plus the summation a n cos 2 pi n x over L plus b n sine 2 pi n x over L. Here, a naught is the average value of the function over one period. A n and b n are coefficients that depend on the function are calculated using integration. The terms cos 2 pi nx over L and sin 2 pi nx over L are harmonics with frequencies that are multiples of the fundamental frequency, which is 1 over L. The Fourier series is particularly useful in the analysis of periodic signals and in solving partial differential equations with periodic boundary conditions. It has application in various fields such as signal processing, communications, control systems, and more. The Fourier transform, which is an extension of the Fourier series to non-periodic functions, is also widely used in engineering and applied mathematics. So we will go through the question.
We are going to presenting our solution for question 1.
So for question 1, the question is related to Fourier series. The equation given is a piecewise function. The first equation is 1 minus x. The interval is -1 is less than equals to x and x is more than 0. The second equation is 1 plus x. The interval is 0 is less than and equals to x and x is more than 1. The function period is f x plus 2 equals to fx. Therefore, we have to sketch the graph on the interval -3 is less than and equals to x and x is less than and equals to 3 to determine the function is even, odd, or neither. And then the second one, we have to write the function in a Fourier series.
For the solution of question 1, we have to determine the period and the length of the graph. For the period, we have to determine by periodic function given by the graph, which is f open bracket x plus 2 close bracket. Then we determine that 2 is the period of the graph. For the length of the graph, we will dividing the period value with 2 and we will get L is equal to 1. As we sketch the graph, we can see that the function is even because it is symmetry to the y-axis. In the graph, it shows that the minimum value in the y-axis is 1 and the maximum value is 2, while for the x-axis, the minimum value is -3 and the maximum value is 3. For the second question, we have to find the function in the Fourier series. Firstly, we have to find a naught. For finding the a-naught, we have to integrate the piecewise function given in the question. Then we inserting the boundary in the integrated equations and we will get open bracket 0 plus 3 over 2 close bracket plus open bracket 3 over 2 minus 0 close bracket. And the final answer for the a-naught is 3.
Next, I will continue the solution by finding the an. The an formula is 1 over L integrate function of x cos n pi x over L dx with upper boundary of L and lower boundary of -L. So the equation goes with integration of 1 minus x cos n pi x dx with upper boundary of 0 minus 1 plus with the other function integration of 1 plus x cos n pi x dx with upper boundary of 1 and 0. After that, we continue this solution by using the tabular method, and we integrate the dv and differentiate the u. Next, we will calculate the equation, and then the final answer of En we got 2 negative 1 to the power of n minus 2 over n square pi square.
So for Bn, the equation is the integration of 1 minus x sine n pi x dx with upper boundary 0 and the lower boundary is negative 1 plus the integration of 1 plus x sine n pi x dx with upper boundary 1 and the lower boundary is 0. So for solving this equation, we need to use the tabular method, which is u and dv terms. We choose 1 minus x and 1 plus x as u and sine n by x as dv. So after that, we need to substitute the upper boundary and the lower boundary in the equation and rearrange and simplify. And the last answer is we get 0, which is symmetrical to y-axis. This calculation for proving that the piecewise function is symmetrical to y-axis. So for fx, just need to substitute the a naught, an, and bn into the function, and our answer is 3 over 2 plus summation in bracket 2 in bracket negative 1 to the power of n minus 2 over n square pi square cos n pi x. So that's all from us. Thank you.